8819. And I'm here to present a seminar with titled Aeroponics into the 4th Century Research Tool. During the course of my presentation, I shall be guided by these arguments. Aeroponics. This is the process of growing plants without the use of soil. Rather, these plants are grown in the air. This is different from traditional methods of growing such as geoponics, where the roots of the plants are inside soil. Or in the case of hydroponics, as seen in this picture, where you have the roots of the plant embedded or submerged in water. This is also different from aquaponics, where the plants are submerged in the appropriate medium while they receive their nutrients from a solution filled with fishes. However, in aeroponics, the roots of the plant are allowed to hang freely in the air, as seen in ball pepper. Another example is the production of yam in the air without the use of soil. As seen in this picture, here we have tubers growing in the air and the roots associated with it. Principles of aeroponics. For aeroponics to function, there are some things that are important. One, we have what we call the reservoir or the nutrient tank. This is where the nutrient is kept for the feeding of the plant. Attached to that, we have what we call the nutrient pump. The nutrient pump supplies the force needed to push the nutrients from the reservoir to where the plants are. And around the place, we have what we call nozzle sprinklers or misters that provides the misty environment around the roots for the feeding of the plant. Also attached to that, we have the timer. The timer helps in the control of the pump to control the feeding time. Also, we have a support system that helps hold the plant in place. As seen in this diagram of Irish potato growing in the air, here we have the supply pipe that brings in, and here we have a sprinkler or a mister that creates the misty environment required for the growth of the plant. Benefits of aeroponics. Because of the sensitivity of the aeroponics system, aeroponics normally is done in a controlled environment, and because the environment is controlled, you realize that there is reduced use of fungicide, insecticide, or pesticide during production. And because the root region is exposed in the air, there is high level of oxygen, and this allows for faster growth as compared to conventional growing. Take for instance, traditional farmers will take 70 to 90 days for the growth of tomatoes. However, an aeroponic farmer will harvest his tomatoes in just 21 days. Aeroponics as a research tool. In the 21st century, different disciplines have already accommodated the use of aeroponics, such as botany, tissue culture, agriculture, and so on and so forth. However, in the 21st century, biochemistry is yet to accept or use aeroponics as a research tool. Some of the importance for the biochemist: one, it has been realized that plants growing in aeroponics has a higher level of flavonoids, antioxidants, and phytochemicals as compared to plants growing in the soil. It has also been realized that with aeroponics, it is possible to study the root and shoot system without having to destroy the plant. Aeroponics has also shown an increase in plant lipids and carbohydrates. Aeroponics will also serve as a tool to move from pharmaceutical era to nutraceutical era. Aeroponics has also shown to help in the increase of shelf life of food, improve the quality of life, and increase the humanity or the lifespan of humanity. According to Sussman et al. In 2014, they carried out an experiment to compare the phenolic content between aeroponic grown plants and plants grown conventionally in the soil. Looking at this diagram, the picture to the left here shows a plant grown in aeroponics at the same age with a plant grown in the soil. Physically, we realize that the plant grown in aeroponics is already bigger. And when we also check the phenolic, flavonoid, and antioxidant properties of both plants, it was realized that the plant grown in aeroponics had higher antioxidant properties as compared to the plant grown in the soil. Thus, for the biochemist, we are important in phytochemicals. You realize that an example of a phytochemical, we have lycopene, which is found in tomatoes, which is said to have protective properties against prostate cancer. First, if the tomatoes is grown in aeroponics, that would increase the phytochemical properties that will help in this fight against cancer. And as I earlier stated, looking at this picture, we have the roots of the plant. This allows for us to take the root of plant to use without having to destroy the parent plant. And I said earlier that aeroponics will help in the movement from the pharmaceutical era to the nutraceutical era. In the 21st century, despite the fact that we have better hospitals, better Medicare, and all of that, yet it is not uncommon to hear that people are dying at the age of 70 or 80, as compared to our forefathers who lived to the age of 120. Yet we have better pharmaceutical companies. Thus, what has changed between them and her has been the quality of food. And according to Hilda Morgan, she said that every time we eat, it's either we are feeding diseases or we are feeding ourselves for life. Thus, if we want to help in the elongation of lifespan of human beings, then we have to move back from the pharmaceutical era to the nutraceutical era. In conclusion, aeroponics is indeed a new frontier, and a lot of questions remain unanswered, and the potentials are endless. For the 21st century biochemists, aeroponics will serve as an extra tool for research by taking advantage of the opportunities that are yet abound. These are my references.